So here we have a cylinder whose radius is r and whose height is h. And we're told that the radius is increasing by 1/3 of a centimeter every second, and the height is increasing 1/2 centimeter per second. That's why I use dr dt, dh dt. dr dt denotes the rate of change of the radius with respect to time. Now, the goal is to find dv dt, the rate of change of the volume, at the moment in time when the height is 9 and the radius is 4 centimeters. So we know that the formula for the volume of pi r squared h, for the volume of a cylinder is volume equals pi r squared h. I suppose I'll make this look like a v. Now, let's find the derivative. So the derivative of v with respect to time would be dv dt. Now, pi is a constant. I'm just going to leave this pi there. So what we have to do is we have to find the derivative of r squared h. That's going to be a product rule. So what I'm going to do is this. I'm going to open up some large parentheses because the product rule here is going to require some space. Now remember product rule. You can do it like this. The first piece times the derivative of the second piece plus the second piece times the derivative of the first piece. If you want, I'll put like little underscores just to emphasize that those are two different functions. And we're going to find the derivative of this piece here using the product rule. So the first piece times the derivative of the second piece. So that would be r squared times dh dt. So the first times the derivative of the second, and it's always plus the second piece times the derivative of the first piece. Well, the derivative of this is going to be 2r times dr dt, right? dr dt, the chain rule. So now we can make the appropriate substitutions. Pi stays pi. R is going to be 4. So that's going to be 4 squared times. dh dt is 1/2. I'll just dismiss the units for now. Addition, h is going to be 9 times 2 times r is going to be 4 times dr dt, which is 1/3. And this is 1/2 of 16, which is 8, plus, let's see, that's 3. And 3 times 8 is 24. So that's 32 pi. So the rate of change of the volume under these conditions is going to be 32 pi, and the units would be cubic centimeters for every passing second. So this here represents the desired quantity.